All right, as always, let me know when you can see me. Sorry, I'm a few minutes late tonight. Took a few minutes longer to put my 3-year-old to bed, so let me know when you can see me. As always, Ali's responding right away. He's on point. Okay. Um, Quick notes for the review tonight. We are looking at parabolas, so those should be fun. However, if you are a regular algebra kid, really just this first one is good for you, but it'll still be a helpful problem to look at for sure. A little bit different than some of the ones that we looked at during class. So basically we're going to look at one in all three forms: standard form, vertex form, and intercept form. Okay, and then we'll also look at converting from standard to vertex form. Those are kind of our major skills. In all of these, we will be trying to find our major pieces of the parabola, which are the vertex, the axis of symmetry, which kind of goes along with the vertex, the x-intercepts, the y-intercepts, and we'll talk about any additional points we have to find. I would say that you should typically always have 5 points. Okay, so basically the vertex and 2 on each side. So without further ado, we'll get into the first one. Vertex. We start finding by finding the x value of our vertex, which is negative b over 2a. And those values are labeled the exact same way they would be in the quadratic formula. So I'm going to circle my a is 2, my b is 8, and my c is negative 6. Okay, so I'm going to do negative b over 2a. In this case, that would be negative 8 over 2 times negative 2. That is a 2, right? Right. Okay, so it looks like my x value, my vertex is 2. That is also my axis of symmetry, by the way. So if I want to explicitly write my axis of symmetry, it'd just be x equals 2. I could even draw a nice dashed vertical line going through 2 right now. To figure out the y value of my vertex, I'm pretty much just stuck plugging it into the equation. Okay, so y equals negative 2 times 2 squared plus 8 times 2 minus 6. I'm literally just plugging it in. Guys, we see this frequently throughout our units, right? When we're solving with substitution or elimination, we find one of the variables and then we plug it in. Okay, so when you know an x value, then plug it in, then you find your y value. Simple as that. Okay, if we do the math here, it looks like we get negative 8 plus 16 is positive 8 minus 6. I get 2. So it looks like we're at 2, 2 here. So our vertex is 2, 2. Okay. Kind of the next thing we'll do here, I'm going to make it in blue because colors are fun. Next thing we want to do here is think about x-intercepts and y-intercepts, okay? And we know this parabola opens down, okay? So I'm not going to keep these lines here, but it's opening this direction. So because we know that, we know there are going to be x-intercepts, okay? So that's pretty good news. So that means we can do that. Okay, so let's figure out some x-intercepts. For x-intercepts, you're going to plug in 0 for y into your equation. And guys, the solving process here then could involve quadratic formula, completing the square, or factoring. I'm going to divide everything by negative 2 here first. And I'll get x squared minus 4x plus 3. And kind of the reason I did that is because now I can easily solve the factoring. Guys, if that equals 0 wasn't there, I wouldn't be able to do that because I'd have an expression. But because I have an equation, as long as I do the same thing to both sides, I'm good. Okay. Now I'm going to solve with factoring. X minus 3, x minus 1 equals 0. Figure out what makes each of those parentheses 0. I get 3 and 1. So my x-intercepts are 3, 0, and 1, 0. I'll plot both of those once again in blue because blue is pretty awesome. Oops. All right. And last but not least, our friend the y-intercept. For y-intercept, you are just plugging in 0 for x. When you do that, this is 0. Gone. This is 0. Gone. And all we have left is y equals -6. So -6 is our y-intercept. Oh, I didn't want it in green. I just wanted the slashes in green. I'm going to fix it. Back in blue. Okay, and then your last point you can figure out by doing symmetry. Okay, so count 2, 1, 2 over to your middle. Count 2 more over. And then, boom, you're making a point there. It doesn't seem to like when I make points. So, in our parabola, when all said and done, looks like that. Oop, I counted too many over on the other side. Just figured it out. Shame on me. Fixed it. Okay. And that's what we look like. So we're all good. Okay. That's the first one. Okay. Next one. We are in vertex form. Okay. The vertex is basically given to us. There's a little bit of work to it. Our vertex is going to be -4, -1. Okay. We actually reverse that value that's in our parentheses with our x. Okay. And the reason we do that is because we're basically trying to make that parentheses equal to 0 to minimize out that part, because that's where we know the middle will be. Okay, so go to -4, -1. That's right here. Okay, and then after that, now we're going to try to figure out x-intercepts, y-intercepts, and all that kind of stuff. All of that stuff is done pretty much the exact same way as it has been before, but it'll be a little bit trickier, okay? And there's going to be a couple things that may cause some problems here, okay? So problem number 1, when we look at x-intercepts, is that we're going to plug in 0 for y, okay? And here's kind of the issue that we have. All right, issue number 1. We're going to solve this for x. Okay, we're going to add 1. 1 equals 1/2 x plus 4 quantity squared. We're going to multiply by 2. 2 equals x plus 4 squared. And now you might see kind of what our first problem is, okay? Because we're going to take the square root of both sides here. And what's going to happen is we are going to end up with a decimal. Okay, there's nothing inherently wrong with a decimal there. It's just that it's going to be a little bit harder for us to work with. Okay, again, this is not really a huge deal, but it's going to make plotting those points all that much trickier. Okay, so what we're going to do, we are going to take the square root of 2, which unfortunately I have to use a calculator for. Like, I'm pretty sure I could guess, but it's not going to go really well. So square root of 2, if my iPhone calculator would work well here, that would be awesome. Square root 2, 1.41. I feel like I should have that memorized by now. So I get 1.41. Oops. Yeah, I'll switch to red. That's fine. 1.41 equals x plus 4, and x plus 4 equals -1.41. Okay, I'm going to solve both of those. And 1.41 minus 4 is -2.59. And I also get -5.41 for this other one. Okay, so my x-intercepts, boy, they're ugly. They're not great. I don't like them a whole lot. Okay, we'll plot them anyway. So this is about -2.59 is somewhere, right about there. Okay, and -5.41 somewhere right about there. If we look at our axis of symmetry, we can kind of see that, yeah, if you just count boxes, it's like both of them are 2 and then a partial box away. So yeah, I guess that does make some good sense. Here's the other facet of things that's going to cause us problems. Oops, no, don't want to clear everything. The other facet of this that's going to cause us problems is when we figure out our y-intercept. Okay, so when you're figuring out your y-intercept, you're just plugging in 0 for x. Okay, but when you do that, you get this. Y equals 1/2 0 plus 4 squared minus 1. Okay, what we end up getting here is, I believe 16 divided by 2 is 8, minus 1 is we get y equals 7. We got a y-intercept of 7. 7 is not currently on our graph. Okay, so we're going to instead need 2 more points. It doesn't exactly matter what they are. I'm going to try plugging in, -2. Okay, and the reason I'm going to try plugging in -2 is because it's kind of close to where those last 2 points were that we made, but not too far away. The math shouldn't be too hard, so let's give it a try. I'm going to plug in -2 for x so I can get 2 more points. Oops, excuse me. 1/2. Oops, not x. -2 plus 4 quantity squared minus 1. And if we do the math, it looks like we get 2 squared is 4, divided by 2 is 2, minus 1 is 3. So we get -2, 3 is an ordered pair. So that's somewhere in that ballpark. And then we'll use symmetry to come up with another one, and oh look, it barely fits. Okay, so we finally got ourselves a parabola there. Hopefully I didn't screw that one up too bad. Oh, drawing doesn't look good though. Ugh, that's okay. Pretend it looks nice. So guys, sometimes what you're going to find is, now I will try to give you graphs that are a little roomier on your exam so you have the ability to maybe plot it like at y-intercept of 7. So like the y-intercept of 7, you know, I mean, like maybe you should be able to plot that. I'll try to give you a little more space. And actually, I think I do a better job of that in the next one. Casey asked, does the 1/2 mean something in vertex form? Yeah, it would actually mean something that's about the same thing in standard form. You know, but like it's just kind of reducing the rate at which that graph is going up. Jason asked, if we forget the arrows, do we lose points? I'm going to try not to be that picky, but please remember, because the graph continues on forever, but no, I'll try not to be that picky. Okay, the last one that we have to graph anyway is in intercept form. So this one's completely different. We actually want to find the x-intercepts first, and the reason is they're just super easy to find. And actually, everything else you do is going to be based on that. Okay, so once what we realize is because we're in a factored form, if we plug in 0 for y, we can pretty easily just solve for x by figuring out what makes each parenthesis 0, which in this case is -3 and -1. Okay, we can plot those right away. I'm having real trouble making dots here. Did it that time. Okay, so there's -3 and -1. The next thing that's really awesome is because we know symmetry works, we know our axis of symmetry has to be right in the middle there. Okay, so that means our x value of our vertex is -2. You're basically taking the average of -3 and -1. Now, to figure out the y value, once you know the x value, same deal as in standard form. You do have to plug that in. Okay, so we'll do that. Okay, and we get, doing a little mental math, looks like -2 times 1 times -1, that's a +2. So -2, +2 is our vertex. Alrighty. And last but not least, we should probably just calculate the y-intercept. It looks like it's going to fit fine. Our graph opens down. Y-intercept is the same as before. You are still plugging in 0 for x. Not even much harder on the mental math here. Order of operations says we get y equals -6. So that is our y-intercept. Okay, and then if I continue my axis of symmetry down, go 2 spaces over, we got ourselves a fancy parabola. Guys, I honestly find this one the easiest to use. Maybe it's just me, but the reason we don't use it a lot is because we don't always have x-intercepts. Connor asked a good question. Do we have to do the dash line for axis of symmetry? No, I honestly, I just like it there because it helps me count. Like, I actually miscounted in the first graph even with it there. So, like, my counting skills are apparently not on point. But no, you don't physically have to put the dash line there. That's totally okay. Last but not least, we need to be able to convert into vertex form. It would help if we kind of remembered that basically what we're gunning for is this, not -2, I'm kind of giving things away there. A times x minus h quantity squared plus k. Now the one thing you got to know in these formulas is that if there's ever plus or minus signs, you can always use another one. It's okay. If it's a minus, it can be a plus. If it's a plus, it can be a minus. That just tells us something about the information we'd be able to pull from that particular equation. We might have to switch a sign or something, right? Like, so if we have a plus in there for our vertex, we know we're getting a negative number, okay? But basically what we're going to try to do is create a perfect square trinomial, similar to what we do when we complete the square. We're going to take out a GCF of -2, but only from our first two. Okay, and actually, you know what? I misspoke a little bit, and I should be really clear here. It's not actually a GCF. It's not. Whatever number that is, -2, -5, negative whatever, positive number, anything. Whatever number is in that A spot, you need to factor it out from the first two, even if it doesn't go in, okay? Because that has to do with the way our final answer looks. And we are supposed to just have an x in parentheses, and that is really all we are supposed to have. So if we have something more than that, then it's not fitting with vertex form. So we have to factor out a in its entirety. Okay, most of the time it's going to turn to a whole number, which is nice. Okay, now we're doing the completing the square step. Okay, so remember the shortcut for that is take whatever numbers with x, in this case -6, cut it in half and square it. Okay, that's a +9. Okay, and sure enough, if you look at that, if you factor it, it factors into x minus 3 and x minus 3. Okay, here's the big thing. You have to balance this out. You basically just threw that blue number that we threw in there, you put it in there. You've got to undo it somehow. Most of the time we do this by adding something to the other side. And if you don't have anything on, I'm sorry, but you don't want to do this to the other side here. You just want to keep it all on this side because we don't have anything over with y in our final formula. Okay, here's what you have to understand. You didn't really add 9. What you really did, if we're looking at the whole right side of the equation in general, you actually added -18 because if you were to distribute that 2, this would be -18. Okay, so the only way to undo a -18 is a +18. Okay, so we're basically doing -18, +18. Okay, now we're just going to put everything together. Factor what's in your parentheses. We've talked about that. It's -3 and -3, or x minus 3 squared. Add those, +1, donezo. Okay. Casey asks, what do we do if we don't have a coefficient for x squared? No big deal. Skip the step or call it a 1. That would be fine too. But really, you don't have to change anything. You just go right into the completing the square step. CCS, when we do complete the square, we have to subtract the new number. No, she figured it out. She figured it out, right? So the big thing is you have to understand whatever you're adding in parentheses is modified by whatever is on the outside of that parentheses. So again, you added 9 in parentheses, but you're dealing then, you're trying to balance it out outside of parentheses. So you have to figure out what it would be if that number was outside parentheses. Okay, hopefully that makes sense. All right, this is a little bit of a quick one, just a quick run through parabolas. We've done them pretty recently. Guys, this is technically my last one. I'm going to try to schedule one on inequalities. I just don't know when. Unfortunately, it might have to be over the weekend sometime, which I know for some of you will be really tough, but at least then we'll have one out there because it's the one chapter that I missed, and it was pretty recent, but I do want to make sure we do one on that. And then we'll have most of our primary topics covered. Okay. Again, hope this is helpful. If you've got further questions on parabolas, come find me and talk to me. #math.